Revision video on complex numbers with our special guest Alex Green. So we're going to start doing a few equations of complex numbers, see how they work, and then I'm going to do a square rooting of a complex number. Okay?
Sounds good, sir. So it appears the equation I've been given is p plus z equals q. Of course, z is a complex number, p is equal to 3 plus 4i, and q is 1 minus I. So we're going to rearrange this equation to get us the value of z. So z is going to equal q minus p. Now we just substitute in the values. So z equals 1 minus I, in brackets, minus 3 plus 4i, which when we take away the brackets means we are doing 1 minus I minus 3 minus 4i, which means that z equals minus 2 minus 5i, and that is your z value.
We're going to square root the number 7 plus 24i. Now, when you're squaring complex numbers, you can assume that the answer will also be complex. And so, complex numbers are usually written in the form a plus bi, where a and b are integers, just real numbers. And so, we know that the square of this should be equal to a plus bi times a plus bi. And we can expand those brackets and we'll get a squared plus 2abi minus b squared equals the square root of 7 plus 24i. So we know that the real parts should link up. The a's, because this is the imaginary part and these are the real parts, that a squared minus b squared is equal to 7. The real parts, and 24i is equal to 2abi. We can cancel out the i's, and so 24 is equal to 2ab. What we can do is it's a simultaneous equation here, and we can write, well, we're using the bottom equation here, label it 2 and 1. We can do 2abi, and we can divide both sides by 2. Then divide both sides by a, and we'll get b. So that's 24 divided by 2 times by a equals b. Now we know what b is here, in the form of an a, and we can put that in this equation here. So that's a squared minus 24 over 2 times a all squared equals 7. We can move this to the right side and move the 7 to the left side. A squared minus 7 equals 24 over 2 times a squared. So we can find out what that will be. 24 squared is 576 over 2a squared, which is 4a to the power of 2. So that's what this is. And then what we can do is we can divide both sides by 4a squared. We can times both sides by 4a squared, and so we should get 4a to the power of 4. We get minus 7a squared, well, times 4, so that's minus 28a squared, equal to 576. Take that away. 4a to the 4 minus 28 a squared minus 576 equals 0. And this is a quadratic equation, but we've got it's a sort of polynomial. We've got the first number is not a squared, and so the second number is just squared. And so what we need to do is we need to let y equal a squared. And then we can write that into the equation, substitute it in. So 4y squared minus 28y minus 576 equals 0. We can put this into the quadratic formula. So this is minus, we'll get minus 9. And if it's plus, we'll get 16. Because it's y squared, let y equal that, so let's square both these numbers to get our two possible answers. Since we know that a has to be real, so it can't be the square of a minus number, because that would be an imaginary number. And so the answer is that a equals 4 for this bit here. And so we can substitute that back in. A squared minus b squared equals 7. We can get 4 squared minus 7 equals b squared. So 16 minus 7 squared. Square rooted. Just 3. B equals 3. And so we can write that in the form ABI, where 4 plus 3i equals the square root of 7 plus 24i.